All right, so we're going to have a quiz today, which will cover chapters 17 and 19. That will be a little bit later. And what I'm going to be doing now is just doing a little bit of a review, what we talked about last time, and then going right into what we call inference. Inference means taking data from a sample and saying something about the population. So well, I'm going to talk about that in a few minutes, but let's go back to chapter 19. And then I'm going to show you a couple slides from chapters 20 and 21, which will apply. Now, I should let you know that we will not be going over chapters 20 and 21 in their entirety. All right, only the first two sections of chapter 20 and the first section of chapter 21 are we going to be reviewing, because the rest of those chapters deal with traditional statistics that if this was a traditional statistics course, we would be using formulas and things like that, and we're not going to be doing that. So, but I do want you to go over, I do want to go over some of the basic ideas that we're going to be talking about.
You said the quiz is 17 and 19?
Uh-huh, yeah.
Okay, thank you.
Mm-hmm. All right. So let's share the screen, and we'll take a look at number 19 here, just to go over a couple slides in number 19. I want to spend a little time on it. Okay. So this is really annoying. This is the PowerPoint is doing this right now. I want me to update the PowerPoint, but
You're muted, Professor.
there we go. So I guess I better start from the beginning. So was I muted from the very beginning? I guess I was.
Yeah, I think like after you got the thing up, yeah.
Oh, I got muted again? I don't know how that happened. All right, so sorry about the being muted. Once again, I'm going to go over a couple slides from chapter 19. We're going to talk about inference, which is the taking information from our sample and making conclusions about the larger population. And so in chapter 19, we talked about sampling. Sampling meaning taking a random sample, right? The different types of random sampling, like simple random sampling, stratified random sampling, and things like that. All right. So we acquire our sample, and then we summarize the data in our sample in two different ways. Now, there's many different ways of summarizing data. All right. We're keeping it to the bare minimum here, the simplest possible summaries. One of them is the mean, which is the average. So if it's a quantitative variable, we're going to add up all the things that we're measuring and divide by the number of values. Right? That's how we do averages. So it's our mean. So we would do that for our sample, right? If we're measuring height, we would add up all the heights and divide by the number of people that we measured the heights of, and we get our average. The other is a proportion, which is for categorical data. We have categories, such as a political poll. We have candidate A and candidate B, and we're asking a categorical question. Basically, which candidate do you favor, candidate A or candidate B? So suppose we're interested in the proportion of all the people that we ask this question to. the proportion of all those people who like candidate A. So we just count up the number of people like candidate A versus candidate B, and we divide by the number of people that we asked, right? And that's a proportion. So these are the simplest possible things that we can ask, right? These are very, very simple, straightforward summaries, right? Nothing complicated about any of that, right? Those two things. Now, once we have our sample proportion, once we have our sample mean, all right, we can also come up with a standard deviation. Now, the standard deviation for a proportion requires us to have an estimate of what our population proportion is, because this is the formula here. We take the square root of this fraction. Square root is the estimated true proportion. Now, proportion, remember, is just a number between 0 and 1, right? It's a proportion of people who like candidate A. All right, that's all it is. Nothing more than that. So it's a decimal, and then we multiply it by 1 minus that decimal. That's what the numerator of this fraction is, and then divide by the number of people that we asked that question to. The sample size, right? That's the number of people in our sample. And we take the square root of that fraction, and we come up with a standard deviation, right? So easy to do, right? You could all do this with your calculator. If I give you this information, suppose 40% of the voters favor candidate X. What's our standard deviation? Square root of 0.4. 40% is 0.4 times 1 minus 0.4. And if we ask 2,400 people this question, that's our sample size. Divided by 2,400, take the square root of that, we get about 0.01. Now, how do we use this information? All right. Well, we can say if we use the empirical rule, that rule for the normal looking curve, right? We could say there's a 68% chance, the sample proportion, that we would get. In other words, we haven't really did the sample yet. We're about to do the sample. And we're asking, all right, what is the chance that our sample proportion is between 0.39 and 0.41? The answer is 68%. Now, where do we get the 0.39 or 39% and 41%? Simple. It's the mean plus the 1 standard deviation. The mean minus 1 standard deviation. So the lower endpoint here, the 39% is 40% minus 1%. The upper endpoint is 40% plus 1%. It's very, yeah, I'm telling you, this is straightforward, all right? Nothing complicated here. I want to give you guys confidence. You can all do this. Don't tell me you don't know math. Don't tell me that. This is just simple stuff that, you know, you all balance your checkbooks and stuff like that. This is just arithmetic, all right? You can do this. It says here 95% chance that the sample proportion is going to be between 38 and 42%. Now, where do we get those? Well, 95% is plus or minus 2 standard deviations. If 1 standard deviation is worth 0.01, 2 standard deviations is worth 0.02. You just multiply it by 2. And then add and subtract that from 0.4, and we get 38 and 42%. And then when they say almost certain, they mean 99.7%. That's almost certain. That's plus or minus 3 standard deviations. That's what it means. Multiply 0.01 times 3, and we add and subtract from 0.4. You get 37%, 43%. Right? So this is sort of a way of estimating where our sample proportion would be with a certain degree of chance. All right, 68% chance that when we do our sample of 2,400 people, we're going to get a sample proportion between 39 and 41%. A 95% chance it's between 38 and 42%. Almost certain it's going to be between 37% and 43%. That's the whole idea. All right. Now, all of this is assuming that we know something about the population. It's a supposed 40% of all voters favor candidate X. Now, obviously, in real life, we don't know that, do we? Otherwise, why are we going to do sampling? Why bother? If we know the population proportion, why bother? So we don't know the population proportion. And so we're going to come up with our sample. And So this particular calculation here, we can't really do it because we don't know that the mean is 0.4, that the population proportion is 0.4. We can't do this. However, if you think about it, what we could say is something like, well, if we do measure the sample proportion, in other words, we take our sample and we count the number of people like candidate X, and suppose, just for example, the number that we get is 38.5%. All right, so 38.5% of the people like candidate X. All right, that's our sample proportion. What can we say about the population proportion? Well, if we know that the sample proportion should be about 1% away, all right, there's a 68% chance that it should be 1% away from the true population proportion. Then if we know the sample proportion, we could say that the population proportion is within 1%, right? I mean, if I'm within 2 feet of you, you're within 2 feet of me. All right, you get the idea? So if the if the sample proportion is supposed to be within 1% or 0.01 of the true population proportion, then we can say with 68% confidence that the population proportion is within 1% of the sample proportion, or 0.01 away. It's the same thing. It's just a distance. It's just a different perspective, you know? That's all I'm saying. All right. And that's what we're going to be doing. We're going to be looking at sample data and trying to figure out with a certain degree of confidence, how close are we to the true population proportion? In this case, it's a proportion. All right. In the same way, if we were measuring a mean, all right, let's get to our mean formula here. This is the rule for sample means, assuming again a bell-shaped curve. The mean, what's the whole idea here, is that the mean of the frequency curve of all the different means. Remember what we're doing here is we have a sample, right? And we find a sample mean. And then maybe all of you in the class do the same type of sample, but you have different people in your sample. Right? So you're going to get different sample means. Suppose we could list all those sample means and draw a curve, and we would get approximately a bell-shaped curve, where the mean is going to be the mean of all those sample means, and the standard deviation would be this formula here. It's the population standard deviation divided by the square root of the sample size. So this is the standard deviation formula. And then we could make those same judgments as we did before, that if we happen to know the population mean, we could say that the sample means should be 68%. 68% of the sample mean should be plus or minus 1 standard deviation, 95% plus or minus 2 standard deviations, almost certain plus or minus 3 standard deviations. The same idea, except the only difference here is that the standard deviation is calculated differently. All right? With a proportion, let's go back to the proportion. With the proportion question, this is the standard deviation of proportion. If it's a question regarding a mean, this is the standard deviation of the mean. That's it. Same idea. All right. And then they show you an example here of how to calculate the standard deviation when the population standard deviation is 5. So if you have 5 is the population standard deviation, and your sample size is 25, that's 25 people. All right. 5 divided by the square root of 25 is 1. So if the mean of the population is 8, we would say that if we take a sample of size 25, we would say there's a 68% chance that the sample mean is between 7 and 9. How do we get that? 8 minus 1 is 7, 8 plus 1 is 9. Because 68% is plus or minus 1 standard deviation. 95% is plus or minus 2 standard deviations. 1 standard deviation is worth £1, 2 standard deviations worth 2 pounds. Plus or minus 2 is 6 and 10. And then almost certain means plus or minus 3. 1 times 3 is 3. 8 minus 3 is 5. 8 plus 3 is 11. That's where they get these numbers. So we can also say, in this case here, if we didn't know the population mean, but if we took a sample mean and we found the sample average was, let's say, 7.5 pounds, all right? That was a sample average of 25 people. We could say, we could add and subtract 1 standard deviation, all right, and say that we're 68% sure that the 68% confident that the true population mean is between those two values, like that. That's exactly what we're going to be doing. All right, so let's now stop sharing and look at chapter 20, just the very beginning of chapter 20. This is exactly what chapter 20 is going to be doing. It's going to be looking at what are called confidence intervals. Confidence interval. Now, what is a confidence interval? It's an interval of values from sample data that is almost sure to cover the true population value. And we're going to, and according to this chapter, you're going to say 95% confident. In other words, if we get a sample statistic, like a sample mean or sample proportion, we'll be able to calculate an interval of possible values that the true population mean is within. And we could say with 95% confidence. I'll show you the formula that they use. Right? It's not, again, not a hard thing to do. They first start off with a proportion, the idea of a proportion. All right. All right. All right. Okay. Now, what they're saying basically is if we calculate our sample proportion, that's the number of people who like candidate X, for example, and divide by the number of people we have, that's our sample proportion. If we add and subtract what they call a margin of error, right, we're going to get an interval, and we're going to call it a 95% confidence interval. We're going to say we're 95% confident that the true population proportion, which is unknown, is inside that interval. That's the whole idea. So let's see if they have an example here. I'll just show you what the example looks like. So here's a poll that was done. Sacramento Bee says 54% of the respondents agreed that gay and lesbian couples could be good parents. So this was and then they said the following. All right, the margin of error is 3 percentage points. 3 percentage points. Okay. All right, so if 54% said they agreed that gay and lesbian couples could be good parents, and they said the margin of error is 3 points, you would add and subtract 3 percentage points. So when you subtract 3 percentage points from 54%, you get 51. And then when you add 3, you get 57. So you would say the confidence interval is from 51% to 57%. Get the idea? So it's easy if you know the margin of error. Now, this slide is a little bit off, by the way, here, because they said in here the margin of error is 3 percentage points, and then they suddenly say it's 5 percentage points down here, which is kind of odd that they would do that. So I'm going to actually 5 percentage points. All right. So just to be consistent with what's down here. So suppose the margin of error is 5 percentage points. If you subtract 5% from 54, you get 49. When you add 5, you get 59. All right. And also, by the way, they messed up here. They should have put 54 here. 54. And I'm going to change these numbers so they match up to what's above. 9 here, and this one here, I'm going to put 59. All right, so does that numbers now make sense? So if the margin of error is 5%, we simply subtract that from 54 to get to 49%, and we add it to 54 to get to 59%. And we could say that we're 95% confident that the true population proportion, that is unknown, is somewhere between 49% and 51%. This is how they do political polling. You know, they'll give you the sample results, and then they will give you the margin of error. Now, the question, of course, is how do you calculate the margin of error? All right. And, well, remember the standard deviation is this square root formula here. And what they do, this is interesting, all right, they multiply that standard deviation by 2. So they take 2 times this standard deviation formula, multiply it by 2, and then they add, and that is called the margin of error, 2 times the standard deviation. And that's how they came up with the margin of error. So the margin of error is 2 times the standard deviation. Now, do you need to know this for our tests and everything else we'll be doing? No. I'm showing you how this is done in real life. This is real life. Or this course, where even though this is a very simple calculation, we're going to avoid it. Because what if we wanted to be 98% confident? What if we wanted to be 92% confident? Some other level of confidence different than 95%. Then this formula won't work. And we would have to go into using a TI-83 or 84 calculator. It gets complicated. There's special formulas, blah, blah, blah. No, we're not doing that. All right. But I wanted to show you an example of what is done in real life. This is how it's done. This is a formula that's used, but it's only used for a 95% confidence interval. That's it. Not for any other level of confidence. In the same way, let's go back. Let's look at chapter 21. And again, I'm showing you just what you need to know for each of the chapters. Again, this is the formula for the standard deviation, the population standard deviation divided by the square root of sample size. This is 4. Then we want to find a confidence interval for a population mean. So we're dealing with means now. All right. This is the formula for it. But if we wanted to find the confidence interval, we would do exactly the same thing. We would take the sample mean that we got, and we would multiply that standard deviation, this formula here, by 2. And we would add and subtract, and that would be our margin of error. Margin of error is 2 times the standard error, or standard deviation. By the way, they call this standard error here, but don't worry about that. I'm not going to test it.
Professor?
Yeah.
Are you supposed to be sharing the screen right now?
Oh, sorry.
It's okay.
Go back. I forgot to share that screen part of it with you. Sorry about that. All right. Here you go. Go back to that formula again. All right. You can see this now, right? You can see it?
Yep.
All right. Yeah. So this is again, the formula for if we were looking at a population, if we were estimating a population mean. This is the standard deviation we would use. Population standard deviation divided by the square root of sample size. That's the standard deviation we would use. And then we would do the same sort of thing as we did with proportions. We would take that formula, the standard deviation, which, by the way, they call standard error here, but again, don't worry about it. I'm not going to test you that information. And then they say, multiply this formula by 2. That's your margin of error, and add and subtract that from the sample mean, and you get your 95% confidence interval. Once again, this only works for 95% level of confidence. It does not work for other levels of confidence. You would have to have a special calculator. You would have to have special formulas. We're not doing any of those things. However, again, I'm showing you in general how these confidence intervals are typically calculated. And again, this is all you need to know, what I'm showing you here, these two slides here in chapter 21. So your question would be, all right, we have this thing called a confidence interval. So we have a sample. We calculate either a sample proportion or sample mean, depending on the situation. And then we create what's called an interval, a confidence interval. And we're saying with a certain degree of confidence that the true population mean or the true population proportion is inside that interval. All right. The question is there an alternative way of doing this? And the answer is yes. Alternative way, and this is the alternative way is what we're going to learn in this class. All right, so we've got about 20 minutes to introduce you to this special software. All right, so what I'm going to do actually is a second here and open up the software. Actually, I'm going to just leave it like that. All right, so I'm going to share the screen here. It's the regular screen. And what I'm going to do is go to a website which is called StatKey. Now, how do you get the StatKey? You can just type in StatKey. Now, I already have it set up here. I just type in StatKey, just one word, StatKey. So make sure you write that down, StatKey. Hit enter. And if you get, at least with my browser, you get directly to StatKey. It gives you the website. Right. It's www.lock5stat.com/StatKey. Click that. And we get to the screen here. So what is StatKey? This was a software that was created using some help from computer programmers, created by this family of statisticians. Now, don't laugh, but this book up here called Statistics Unlocking the Power of Data, which, by the way, I have a complimentary copy of it, and I will be using it for this part of the course. Now, you don't have a copy of it, but I will. I do have access to. I think the Wiley is the publisher. I believe I have access to their website, and I should be able to show you some things from this book. But regardless, the authors are Lock, and Lock. Now it's not a joke. This is called the Lock family. They are all statisticians. There's a husband and wife and 3 children. Believe it or not, they are all statisticians. Right. So this is a family affair. They all became statisticians. They all, at one point in time, taught statistics, and they all helped to create this textbook. Now, they believe that it's helpful when we talk about confidence intervals to come up with an alternative way of viewing them. And in this course, that's all we're going to look at is the alternative way of viewing them. We're not going to actually go to the formulas, but in their textbook, they eventually do go back to the formulas so that you have a better idea of how they work. But we won't here. And basically, StatKey here has different things that we can look at, and they have different data sets that are in StatKey. I'll show you give you a sort of a brief overview of it. So what we're going to be focusing on here are these 2 columns here. There's one called bootstrap confidence intervals, and another one called randomization hypothesis tests. But there are 2 types of inference that we're going to be doing for the rest of this course. One type is called the confidence intervals. I've just been talking about that. The idea of estimating a population mean or population proportion using interval values. All right. I showed you in general how to do it in a simple way with some formulas, but I now want to show you how to do it with the software. So that's one thing we're going to do is we're going to show you next time on Thursday. I'll show you how to do confidence intervals with in the middle here, and I think it'll continue next Tuesday also. We'll have 2 sessions. I think the syllabus says 3 sessions, but I'm running a little behind, so I'm going to make it 2 sessions. I'll show you how to use the software to create these confidence intervals. And then the last part of the course, we're going to do what's called hypothesis tests. And a hypothesis test is something like we have a hypothesis of what the population mean is, what proportion is, and then we're going to use sample data to test, to see if there's enough evidence from the sample to conclude whether that population mean or population proportion seems correct. All right, so there are formulas for doing that in regular statistics course, but we're not going to be using formulas. We're going to be using stacking. All right. There's other things in here, sampling distributions, and other things that might be useful in a regular statistics course. All these other things here, we're not going to be touching any of those. First column here, descriptive the statistics and graphs, might be useful, but we're not going to be using it. We're just going to be using these 2 columns right here. And we're going to start off in the next 2 sessions, Thursday and next Tuesday, looking at this here. All right. Now, suppose we wanted to know a little bit more about StatKey. One thing we can do, we don't have time right now, I don't think. No, we don't. We only have 15 minutes. But I'm going to have a little assignment to you that you're going to be doing. So if you click this link here, it says Statistics, Unlocking the Power of Data, you will get to this screen here. Now, they do, of course, have their textbooks here. This is, of course, they are advertising their textbooks. By the way, this is the family. Obviously, Dad and Mom are sitting down, and the kids are standing up. They're all grown. And by the way, this guy, I believe here, the guy on the left here, is actually a statistician for a professional baseball team. One of the, I don't know if it's the Marlins or some other team, but he's one of their major statisticians. He used to teach, but that's what he does for a living. And these other 2 children, if you call them children, they're both married. They are also educators, just like Mom and Dad are. Right? Mom and Dad. All right. And anyway, they have a whole bunch of things that you can look at. Now, the textbook, of course, you can click here and you can get information about the textbooks, but of course, you have to buy them to actually get them. But don't worry, you don't have to buy them. Now, if we click StatKey right here, StatKey here, you click that. So we scroll down to get to StatKey and click this. We're going to, oops, we get back to our main screen. So it's not really what I wanted to do, but that's what we just did. So I'm going to click this once again, go back. Now, so that's how you get back to the StatKey screen if you are here. Just click StatKey. Now, if you go down to videos and click that, they have introductory videos. All right. So what I want you to do is, as an assignment for next time, I want you to click the video called Introduction to StatKey. It's going to give you an overview of all the StatKey features. Remember, we're only going to be using 2 of those features, but it's a good video. It takes 21 minutes. Again, we don't have enough time today to do it online, and I don't think it's kind of a waste of time to do it online when you can watch it yourself. This is your assignment, all right? Your assignment before the next class is to watch that video. Now, if you want to get a little bit of a head start on confidence intervals, you could also watch this video, Overview of Bootstrap Confidence Intervals. May not make a whole lot of sense to you at this point, but if you want to, you can do that. Or you can wait till I have my session next time, and I will go over how to create those. They have an introductory video on that. And then when we get the randomization tests, the last part of the course, they have a video for that too. So it's very nice. You have these introductory videos, but I definitely want you to watch Introduction to StatKey. Please don't ignore this. All right, don't do it. It's very important to watch this video because it's going to give you a way of moving around. And if you come to the class and you don't know what's going on because you didn't watch the introductory video, not my fault, it's your fault. You didn't do it. Do it. All right. This is not 21 minutes of your time. Take 21 minutes of your time. There's nothing else that's assigned from here to till Thursday. So you have 2 days, or excuse me, 1 day, the rest of today and tomorrow to watch. Take 21 minutes at a time and watch this. It is required. All right. I'm just telling you, it's required. Don't ignore it. Watch it. All right. Again, you may not understand everything the person's saying, but at least you'll be able to move around in StatKey, and you'll know exactly what I'm talking about when I'm moving around. Again, if you want to take, if you have additional time, take a look at the overview of Bootstrap confidence intervals. But that will be assigned next time for sure. But if you want to get a head start, you can watch that one also. All right. So that's your assignment. That's how you get here. Again, once again, if you want to get back to StatKey, you click StatKey. And to get to the screen we were just in, you click this link up here. Okay? And then you get down to videos. That's how you find it. All right, click videos. Any questions about that? All right, so let me just show you a little bit about, we have a few minutes. We have about 9 minutes. So I'm going to give you a little bit of an introduction about StatKey, but I'm not, again, that video is going to give you a better overview than I'm going to give, because they're the ones who created it, obviously. So to get back to StatKey, I'm going to hit StatKey. Now, this particular section here is Bootstrap confidence intervals. So I'm going to look at CI, by the way, stands for confidence interval. All right. So I hope that's obvious to you that that's what it means, but I should bring it to your attention. So confidence interval for a single mean, median, or standard deviation. By the way, we're not going to be looking at confidence intervals for medians or standard deviations, only for means. So that's the only one we're interested in here. I'm going to click that. And you're going to get a screen that looks something like this. All right. So let me just give you a general overview of what these screens look like. And I'll just do a couple things. And again, the video is going to give you a more comprehensive introduction. Now, the StatKey comes with data sets that already are put in here. So if you click this little first box here, you can see here are all the data sets that are used for this program. So we'll use one of them here, for example. And we can just use that first one. This is Mustang price. Mustang, of course, is a car. And so we have this data set called Mustang price. Now, if we picked another one, we could pick restaurant tips. We get another one. Okay. Actually, let's take the restaurant tips. That would be all right. All right. Now, what is restaurant tips? These are I guess, the amount of money that was given as a tip for a meal. All right. So we've all done that. So what is the sample involved? There's 157 people who are basically asked, how much do you typically tip at this particular restaurant? All right. So there's 157 people who go to this restaurant and we determine how much the tip is. And this is a dot plot. If you remember dot plots, right? Dot plots would be the quantitative variable is down here, and each dot represents the answer to that question, what is the tip? Some tips were very small, like 25 cents. Can you picture somebody giving a 25-cent tip? And then we have a very big tip out here, $15 tip. And most of them are in the middle here. And what's interesting, if you move your cursor around, and I would highly recommend that you use a computer for this. Don't use iPad or your phone. All right, got to use a computer. And by the way, for the rest of this course, use your computer. Use a computer. If you don't have one, use somebody else's computer. But you need to use a computer. All right, absolutely, absolutely, and make sure that the video units working and all that. All right, very important. So anyway, here are all 157 of them. Count the number of dots, it'd be 157 dots here. And what we have is the mean is 3.849. In other words, we took all these values, right? And notice as I move around, if I just highlight, if I put my cursor over a dot, it tells me how much that value is. 2.750 here and 3.55 here. Just get the idea? This cursor tells you what the value of that dot is. Now, obviously, a dot plot, there could be a number of people with the same restaurant tip. In this case, $2, or it's around $2. But anyway, all these numbers are added up and divided by 157 to get the mean of 3.849. That's where they get it. Now they calculate it for you. That's our sample mean. Now they give you the median and they give you the standard deviation. All right. Do we need the median and standard deviation? No. But be careful. If I give you one of these, if I display one of these to you on a quiz or a test and ask you for the mean, make sure you look at it carefully. Here's the mean. Here's the median. Here's the standard deviation. And by the way, people are just coming in for the quiz. Bad idea. Please, I hate to be critical today. Don't just come to the class for the quiz. You're missing all of everything I'm telling you. Now, of course, I'm recording it, but it's not a good idea to come late just for a quiz. All right, you should be sitting in the entire class. And I'm not going to give you full credit for attendance if you're just coming in the middle like this. So whoever this was that just came in, I'm not trying to embarrass you or anything, but don't do this. All right, come in at the beginning of the class. All right. Anyway, got sidetracked a little bit. Now, again, they're going to explain this on the video. Make sure you watch the video for this. It shows you how to use StatKey. But suppose I wanted to create what's called a bootstrap sample. Now, what is a bootstrap sample? Somebody is chatting here. All right. Okay. All right. Anyway, what is a bootstrap sample? What they explained it a little bit in that second video, the one they talked about bootstrap confidence intervals. But basically, what happens is they take the original sample. Now, the original sample are 157 people. All right. So once we ask one person how much they gave as a restaurant tip, that person's done. All right. But a bootstrap sample says we're going to do what's called sampling with replacement, which means we can reuse that same person again. In other words, once we choose somebody and we record their answer, we put them back into the pool of people, 157 people, and then when we choose the second person, that person could be chosen again. So what happens is when we find the mean of a bootstrap sample, it could very well be different than the mean of the original sample. Right, so it's called bootstrap samples. So if I wanted to create one of these bootstrap samples, I would typically go, there's on the upper left here says generate one sample. That's a bootstrap sample. I generate one of them. It actually displays all 157 values that were chosen. And notice that the average for that bootstrap sample is 3.876. Notice, by the way, if you compare the original sample to the bootstrap sample, that in the original sample there was somebody gave $15. It didn't show up in the bootstrap sample. All right, that's because there was other people who were chosen more than once. All right, so these bootstrap samples will typically give different answers. If I create another one, notice this one is much lower as the average. It's 3.659. Notice that they show you the mean right here. So this is the mean of bootstrap samples. So I've created 2 of them. I can create 10 more. I can create 100 of them. I can create 1,000. And I end up getting a plot that looks like this. And each one of these dots inside the plot is a bootstrap sample of 157 people in the sample. All right, each one of these. And notice that the averages run for, now the average, these are the bootstrap sample averages, run from 3.3 all the way up to 4.45. So 3.3, it actually says 3.292, all the way up to 4.45. All right. So anyway, that's it. That's an introduction to, and obviously you need to listen to that video. Please do so. And I'm going to stop sharing now, and your quiz should be available. So go ahead and start the quiz. Give me a thumbs up if you see the quiz.
All right, mine's is locked, Professor.
All right, go back out, go back in. All right. You should know that by now, right? If you're having trouble, go back out, come back in. All right. Thank you. There's nothing I can do from my side. All right. There's nothing I can do. All right. I don't have that control over your computer. So please go back out and come back in.
You're right. Yeah, you're
All right.
right.
Thank
You
you.
got
Thank you.
back
Go
out.
ahead and do
Okay.
that.